Chemical formulas. A molecular formula is a representation of a molecule or compound which consists of the following: chemical symbols to indicate the types of atoms, subscripts after the symbol to indicate the number of each type of atom in the molecule. Subscripts are used only when more than one of the atom is given of a given type is present. So when we write out a molecular formula, I'm sure you've heard of water before being H2O. H2 means that there's two hydrogens, and O means that there's one oxygen. We don't write the number 1 because otherwise, if there was 0, we wouldn't put the O there in the formula. So 1 is always assumed, and then any number above 1 is going to be written in the formula. A structural formula shows the same information as a molecular formula, but also shows how atoms are connected. So here you can see methane. Methane is CH4. There's 1 carbon and 4 hydrogen. So these subscripts down here tell you how many of that atoms of that type are present in the formula. And here you can see it drawn out. So this is a structural formula. So you can see the carbon and 4 hydrogens. Then there's a ball and stick model, which looks like this, and a space filling model. In this class, we will be looking at A and B quite a bit, and we'll learn how to draw out structural models like this. We will not really focus on C and D. Here's just another example. Here's benzene. Benzene is C6H6. So C6 means that there's 6 carbon, and H6 means that there's 6 hydrogen. So here is our structural model, our ball and stick model, and our space filling model. And then here is benzene as a clear liquid. Many elements consist of discrete individual atoms. Some elements exist as molecules. So diatomic molecules exist naturally in nature in pairs. You should be familiar with these diatomic molecules. Assumptions in this course are going to be made that you understand that these are diatomic molecules. So as we get into higher levels of stoichiometry and such later on in the course, it is going to be assumed that you know if I write out oxygen in a word problem, you know oxygen naturally comes as O2. So make a note of these diatomic molecules because this is how they naturally exist in nature. They are going to be in pairs. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. The most common form of elemental sulfur exists as S8. So this is a picture of sulfur, structural formula, ball and stick, and space filling model. The symbols H, 2H, H2, and 2H2 are very different. So H is just 1 hydrogen atom. When we put a big 2 in front of it, we're talking about 2 of the individual hydrogen atoms. So they are 2 separate entities. H2, where we have the subscript, that means that there's 2 hydrogens bonded together. So these are going to be closer together. And 2H2 means that we have 2 molecules of hydrogen. And the hydrogens are bonded together as diatomic molecules. So going a little bit deeper into chemical formulas, H2SO4. This is a really good diagram because it shows you what each part of this means. So H indicates the element hydrogen. This subscript 2 means that there's 2 hydrogens in this compound. The S indicates the element sulfur, And since there's no subscript after sulfur, there's just one atom of sulfur. The O is oxygen, and this subscript here means that there's 4 oxygen. Here's another chemical formula. When we use parentheses, it's kind of like using parentheses in algebra. Anything outside of the parentheses has to be multiplied inside of the parentheses to get the total number. So here we see there's 1 calcium, and it looks like there's 1 nitrogen, but because this subscript 2 is on the outside, that means that we actually have 2 nitrate groups. And in the nitrate group, we have 1 nitrogen, 3 oxygen. So when we do the math, 2 nitrogen and 2 times 3 gives us 6 oxygen. So we carry in the 2 and apply it toward the nitrogen and the oxygen. The formula for table sugar is C12H22O11. How many oxygen atoms are found in a molecule of sugar? So it's 11. Aluminum sulfate is a compound that is often found in baking powder. How many sulfur atoms are found in Al2SO4-3? So 3. And why is it 3? Because we carry in this subscript to the S and to the O. How many oxygen atoms are found in Al2SO4? 12. Again, we're going to multiply. So 3 times 1 is 3. 3 times 4 is 12. So we have 12 molecules of oxygen. 12 atoms of oxygen. The formula for ethyl alcohol is CH3CH2OH. How many hydrogen atoms are found in a molecule of ethyl alcohol? So with this one, you're going to add them up. So we have 3 hydrogen here, 2 hydrogen here, and 1 hydrogen here, and that gives us 6. Empirical versus molecular formulas. So one of the course competencies says that we have to describe and be able to calculate an empirical formula. Empirical formula indicates the simplest whole number ratio of the number of atoms or ions in a compound. A molecular formula indicates the actual numbers of atoms of each element in a molecule of the compound. So if we look at benzene, the molecular formula is C6H6, but the empirical formula is CH. How did we end up with that? Well, if we reduce these to the lowest common ratio, we can multiply each one of these by 6, and that gives us CH. So for every 1 carbon, there's 1 hydrogen. The molecular formula for acetic acid is C2H4O2. If we divide all of these by 2, we can get to our simplest empirical formula, CH2O. So at this point, I would like you to pause the video, determine the empirical formula for the following compounds, and then in a little bit you can unpause the video and we will go through the answers. Okay, so hopefully you had a chance to pause the video and work through these. So the simplest ratio of these, we can divide everything by 6. So this becomes CH2O. Because if you divide this by 6, that becomes 1, that becomes 2, that becomes 1. So CH2O. CH4. We can't reduce that anymore. That is the empirical formula. So this one is what it is, CH4. And that happens to be methane. H2O2, we can divide each one of those by 2, and that just becomes HO. It may be possible for the same atoms to be arranged in different ways. Isomers are compounds with the same chemical formula but different molecular structures. Iso, again, means similar. So isomer means that they're similar because they have the same chemical formula, but they're not exactly the same because they have different molecular structures. So for example, acetic acid and methylformate both have the molecular formula C2H4O2, but they have different structures and properties. So here's acetic acid, and you can see how this one is structured. But if we rearrange this, and we put the oxygen here, and move the carbon up here, and have the hydrogen off the side of the carbon, it becomes methylformate. Even though they have the same chemical formula, C2H4O2, they're structured very differently and they will behave very differently in nature. Isomers exist in many different places, and this is what gives chemistry and chemicals their unique ability to be multiple things and to do different things. And then here's just a picture of spatial isomers, so you can see they're mirror images of each other. But even being mirror images of each other makes them very different compounds.